okay? This mic is actually for the camera, so I guess you guys can hear okay in the back? Okay, great. So again, welcome. I guess, again, first of all, thanks for coming. I know all of you guys are very, very busy, so we are very appreciative of the fact that you guys have taken time out of your schedules to come. So means a lot to us, and we're very appreciative. So I guess Chamber of Commerce weather, we couldn't have planned that any better. I said that to someone earlier, but very fortunate, and thanks to Felicia and Kristen and Megan for picking the spot and getting everything set up for us. So I think we're gonna have a good event here. So just a couple things for those of you that have attended before, you kind of get what this is about, but for those of you that haven't, we kind of have 4 objectives, at least when internally we start talking about this, of what we want to accomplish with this event. Number 1 is, I'll call it a mini training, sharing from our perspective as kind of the mad scientist, engineer folks that are working at your facilities. What do we see and what are we thinking and how do we think when we're at your facilities? So kind of sharing that perspective to you guys. A little bit of, I'll call it current events, kind of again, what's going on in the industry, and talk through that and share again from our perspective what's going on and maybe what you guys need to be thinking about and considering. And then also taking an opportunity, what I'll say, go to the balcony, the 30,000 foot perspective of some of the issues that have plagued the industry, what are we doing about it? So kind of going up to the 30,000 foot and talking about that, that's what we always try to accomplish of, kind of bigger picture, taking away from, where we normally are of consortium meetings and things like that. There's other business that we're focused on. With this event, the idea is let's talk about, have some time to share on those issues and what are we doing as an industry and how can we get better. And then lastly, most importantly, is the networking part, which again, we just kind of did that. You could see we probably could have stood here for another 3 hours and just chatted, but we'll do the Royals game. We have several breaks built in, the activities this evening, et cetera. So that is it. Again, so kind of our theme for this year was, where's your risk? So honestly, this is our 5th year doing this, and that's been kind of a common thread throughout all of, each of the seminars is each time we talk about, what are the risks that we see from our perspective for the operations that you guys own? And then what can we do to make that better? Again, I think we've made a lot of progress over the last several years, but there's always stuff. There's always something. That's part of running a business, is how do you manage risk versus cost and find that kind of happy medium. But a lot of what we put together as far as the speakers and the presentations and the folks that we asked to come talk to you guys is to speak to that. As we go to your facilities and we see things and we're talking with all the different people, the various stakeholders that play a part in this, what are we seeing and, what advice, I guess, if we'll call it that, do we have to help make, better, more informed decisions with the end game of operating better, reducing risk, finding ways to be more efficient, obviously with cost in mind and all of that. So all the speakers that we've teed up are going to speak to that in a different, for different pieces of this. But that was kind of the common thread for us, is to make sure that we're talking about, again, things that we're seeing and how we can support you to move that forward. I'm not talking about that. I was looking at your slides off to the side. Okay, so again, welcome everybody. Please, we want this to be interactive, so jump in, ask questions with any of the speakers as we're going through this. Again, the idea is to make this, a learning opportunity, but also get to visit with your peers and whatnot. So go ahead, Felicia. Or I guess I can do that now, right? Okay, so our first presentation is with Joe Francis and Terry Manning, and I guess I can click through this, right? So Terry is actually leads our fire protection side of our business. Former fire marshal, also has been in industry on the engineering side, designing fuel facilities and firefighting equipment at fuel facilities. And then Joe Francis is also going to help with this. Joe comes from having worked at the City of Phoenix on the environmental side of the business and also construction, but he leads our environmental practice. And they are going to be discussing AFFF, or foam, firefighting foam, that I'm sure you guys have heard a ton about this, but kind of give the broader perspective of what's going on and what to be thinking about. So who gets to go first?
So I'm Terry Manning. I'm your fire protection guy, and I've spoken to many of you either on conference calls or in person. We're going to talk about AFFF. Not a fun thing to talk about today. Not fun at all. So here's basically, I'm going to run through very quickly how the systems work for those of you that are just peripherally knowledgeable. And for those of you that already know, just watch. So first thing we need is a water supply. That water supply can be a municipal water supply or stored water on site. We have airports with both. Second is a fire pump, because we need a lot of pressure. We don't need the pressure for the foam system itself in the tanks. Where we need the pressure is for the cooling nozzles on the adjacent tanks, should there be a fire. Foam concentrate storage vessel, that's where the big steel drum, the foam concentrate, the liquid that's in it, and we're talking AFFF now, today, because that's the FAA 139 rule. It's going to change, and it's going to change soon. The piping network, so we've got the foam piping that goes up to the scuppers in the top of the tanks from deluge valves, and we also have the cooling water, which doesn't have any foam in it. The tank foam chamber, and then the fire alarm panel, which is the key to this whole thing. It's a PLC, and it directs, depending on what you've selected. Say, for example, there's a tank 3, a fire in tank 3. By pulling the alarm, the pull station for tank 3, you activate the foam for that tank only. But you also activate the cooling nozzles for the adjacent tanks, all done through the PLC. So the operator activates the manual pull station, the fire alarm panel, which is incidentally, it's UL listed. It's a fire alarm panel, but it's UL listed for what they call releasing devices. So it's got special circuitry in there to monitor the release of the foam and the deluge nozzles, the deluge valves. Water flowing past the foam inductor draws foam into the water. So what we have here is a typical fire equipment room. We've got the fire pump, the lineup of deluge valves, one for each tank, and then one for each cooling water monitor. And then we can just see the side of the vessel here, the bladder tank. And then typical, as we all know, here's the fire water, or the foam line coming across the bridge, around, and then up the side. Depending on the diameter of your tank, you can have 1, 2, 3, or 4 foam makers at the top of the tank. Typical layout. So there's 4 here, 4 here. This is subsurface. We'll talk about that in a second. So here's your foam control building, just the lines feeding out, and it's all operated by the fire alarm panel. These are top foam systems. This is a show of a bottom injection. So we can either have foam coming in the top, which is the normal way of doing it, but some of the older technology had bottom injection of foam. And the way that works is there's a pipe and then a diffuser inside at the bottom of the tank. But where the foam pipe enters the tank, there's a burst disc. And that's sitting between 2 flanges, kind of like a blind flange, but it's a burst disc. And if the system's called upon to operate, the excessive pressure from the fire pump bursts that disc, and allows the flow to foam in below the bottom of the tank and then float up. That's older technology, and one of the reasons that it was used was in case there was any physical damage to the top of the tank, that you would still have an ability to get foam into the tank. So we deal in maybes. So maybe there's a plane incident and it takes off the top of the tank or smashes into the top of the tank and takes that foam system out. Or maybe there's a lightning strike which causes a serious explosion which could take that out. Very, very unlikely, but that was the idea behind this technology. So similar systems that we have are truckload and unload. Interesting, if you've got a canopy over your truckload unload, you have to have a fire protection foam system in that canopy. If you don't have a top on it, you don't need any fire protection at all. So there won't be a fire if you have no roof. Pump pads, dikes, tank cooling, and miscellaneous things. This is an example of a tank cooling nozzle. Depending on the diameter of the tanks and the distance between, shell-to-shell distance between tanks, we either have 500 or 750 gallon nozzles with usually 2 per face so that we can adequately cover the side. This is, well, go back. So this is for a truckload, unload, or a pump pad. This is actually a foam nozzle. And you can see this is the line that draws the foam from totes or 55-gallon drums, draws it up. It's a manually operated system, usually by the fire department. You don't see them very often, but they do exist. And then this is obviously a filter pad, pump pad with nozzles, ultraviolet. So these are UV-IR, ultraviolet infrared detectors that watch the pad. And they activate the deluge valve, and that deluge valve sends foam to the nozzles that are up on stanchions and basically just drowned it. Questions? Everybody cool with that? All right, Joe. Here's how it works. So you've got a fire. We bring in the foam, and what the foam does is the foam layer has got a surfactant in it, which is what's really the problem now. It's the fluorine surfactant, which allows that foam to race across the surface of the fuel. That's where the PFAS comes in. Then it isolates, cools, and then draws over the top of the fire, occluding the oxygen and basically controlling the fire. Now it's Joe.
Here is I call the family tree here. Because when I first got involved in this in Argus, it's like, what in the heck am I looking at this? This is from 40 years ago in chemistry class, and I don't even know if I even studied this. So, but the PFAS that you're hearing about today, the perfluoral and the polyfluorals. The perfluorals are up here, and right now, I even have what we're talking about today in the EPA level is the regulation of the PFOA and the PFOS. That's the perfluorals. And then you also have these other ones here off that branch, and I'll tell you, EPA is right behind them, right behind these as well. They're coming for these as well. And then you'll see over here polyfluoroalkyls. Those are going to be regulated in the near future as well. But the ones here on the right-hand side are really what they're going after today, starting with these two, the PFOA, the PFOS. And just breakdown here of what's the problem that we're dealing with. And here's the chemical structure for 2 perfluoroalkyl substances. And what you have here, if you remember from your chemistry class, if you took one, is that you have a straight chain carbon here with fluorine molecules, either in the blue here or the green on this one. All right, and then at the very end here, this is what differentiates between a per and a polyfluoroalkyl substance. And right here, this is a combination of hydrogen, oxygen, sulfur, and even some of them get creative and add nitrogen, other chemicals here. The polyfluorols are when you take away a fluorine molecule here and here or along anywhere but from the end, right here. And if you replace one of these up here with replace the fluorine with like a hydrogen, then you're into a polyfluoroalkyl substance. So there'll be a test on this later, folks. As I said, current foam, AFFC. Boy, Lloyd, we're going to have to leave the room. AFFF concentrate. Oh, I'm sorry. AFFF concentrates that are currently available are the short chain, C6. So if you took that slide I showed earlier, which were C8s. It sure does. It doesn't like me. If you were to cut off this right here, you'd have a C6. And that's really the difference. That's currently what's available today for probably several more months. It's available. And that's what's in probably most of your systems, or if not, the old C8. Typically, out of my own curiosity, PFAS in a foam barrel, it's basically, or in a bladder tank, is basically the concentration is only 0.9 to 1.5% on average. EPA's reported up to 2% of foam has PFAS in it. So it's very small concentration. The foam, of course, meets the current the DoD mil spec and FAA Part 139 requirements. UL listed. FAA, of course, accepts the foam that only the DoD mil spec standards only meets DoD mil spec standards. However, as you all know, the DoD is preparing a draft specification for fluorine-free foam. And that will be out for public comment and approval early next year, I believe. Once the mil-spec foam is approved, the FAA is going to then adopt that specification, and then there starts the transition to replacing the AFFF with the fluorine-free foam products, the triple Fs now. We don't know the timetable yet, but it's coming soon, very soon. It'll be next year probably, if all goes to plan at the federal level. And for environmental concerns, releases of the C6 and C8 foam have significantly impacted drinking water resources across the United States. Once it's released to the environment, it's again it's not easily destroyed in the environment. PFAS are not biodegradable. They're not removed by conventional wastewater treatment or incineration processes. You'll notice I put this here. Basically, in my research is that you need to get above these temperatures to ensure that if you're incinerating a PFAS contaminated, either it's media or foam concentrate, you want to get above those temperatures because there is an emissions from the incineration process, and they found that there's still traceable amounts of PFAS in those emissions, which is not good. You want to try to get it completely destroyed. Some will say that they can get it destroyed up to like 99.9%, but it's a concern. And so when somebody says they can incinerate it, you want to make sure that they can do thermal destruction literally at a very, very high temperature and not a conventional temperature used for like non-hazardous waste. In 2016, the US EPA came out with a long-term health advisory that's it is not enforceable. It is a health advisory only of 70 parts per trillion PFAS. And that alone affected approximately 6.5 million people's drinking water systems in the United States alone. When you see EPA here, the EPA, as you know, has been in a rulemaking process, and they've been going like gangbusters, for lack of better terms, for the last year. The regulations are soon to be in draft right now. They're going to be put out for public comment. But that's the extent that we're going to take it, because Lloyd Landreth's going to give us an update here on the federal rulemaking and the state regulatory rulemaking processes that are going on right now. And on the right-hand side, you'll see here the concern with PFAS is it's not only in the firefighting foams, but it's also found in, if you can see the screen here, but stain-resistant products. I mean, I love Carhartt. Now I have a closet, several winter jackets full of PFAS-containing clothing. Fast food packaging, it used to be the pizza boxes. I understand that still the popcorn bags in the microwave popcorn actually has some in it. And so the popcorn doesn't stick to the side of the bag when you're getting ready to watch a movie. You believe that? Of course, I call this the grandfather of all of his Teflon nonstick cookware. I believe this is where with the invention of Teflon has led to many of these compounds of which the PFAS family is part of. So no good deed goes unpunished. Paints, of course, pesticides you can find in, even shampoo. I don't know. And then this is I hope you all can see this, but I found this drawing here of how the exposure pathways, how PFAS ultimately ends up in our bloodstream. And it's either through, construction workers can be exposed through drinking water or vapors, dust on the work site. Of course, I should have jumped ahead. But what do they show here as the classic example? Is an airport, and even, of days of the long gone burn pits, which I haven't come across one in 20-some years. But you can see here that the various exposure pathways, how it gets into the plants and animals, basically through their diet. And then ultimately up the food chain it goes and into us. And again, I said, the health effects of it is basically cancer, liver and kidney disease, birth defects, and even impaired child growth too. So if exposed to high enough numbers. If you all can see the screen, there's one thing missing. Did you notice it? I have yet to find it. There's no storage tank for it. There's no tanks here. So, what is a 1 part per trillion? What is 1 part per trillion? Which, again, it's 1 times 10 to the negative 12th. So it's a 1 with a bunch of zeros ahead of it. Well, it's something. Okay, there we go. 1 part per trillion is equivalent to 1 drop of water in 20 Olympic-sized swimming pools. Okay, and let's take an average. Olympic-sized swimming pool has 660,000 gallons in it. Take it times 20, and I think you're at 13, I'm a geologist, I'm not supposed to know that. 13 million some gallons of water, and we're talking 1 drop. Okay, it's also equivalent to 1 second in 31,700 years, or 1 minute in the last 1.9 million years. Okay. So, fluorine-free foam. Now we're getting into the good stuff. It's the new foam developed for firefighting applications. It's environmentally friendly, at least it is supposedly going to be so far. And it contains less than 1 part per billion PFAS, Or if you read the draft military specification, less than 1 part per million fluorine, 1 part per billion fluorine. I think that's going to may even be changed. And the reason I say that, it almost seems like a high concentration, even though you're talking 1 part per billion. You have to, 1 part per trillion is, it takes 1,000 parts per trillion to equal 1 part per billion. The fluorine-free foam concentrate, the FFF, I'm sorry, I'm environmental, so we just deal with nothing but acronyms. But fluorine-free foam concentrate is also called F3 or NFF, non-fluorinated foam, depending on the manufacturer. And in the near future, we're all going to be bombarded with new products out on the street. Not all these new FFF concentrates are equal with respect to compatibility with existing fire protection systems. Oh, I'm stealing your show.
Do that last one.
You got it, boss.
Please step off of the ledge. I did.
Oh, you did?
Yeah. So the last point here is very interesting. You have existing systems. You have existing bladder tanks. Some of you may have vats, depending on the size of your facility. You may have a 500 to 3,000 gallon vat. For example, O'Hare Field, they have 2,000 gallon vats of concentrate. They're poly vats. Most of us have the tanks. As we went through earlier, the way the foam gets into the water system, it goes out of the tank. When the valve trips, it pressurizes the outside of the bladder inside of the steel shell. So basically it's squeezing it out like ketchup. But it goes through an adductor and then it's drawn into the water system, into the water flow. That ratio of adduction against the pressure against the inside of the shell has stainless steel piping that feeds from the bladder to the injector. Now that stainless steel piping can be as small as a 1/4 inch or it can be as large as a 1/2 inch. That's all contaminated. That's got the raw contaminant on it and has been since the day it was put in there. But that's adjusted for a application rate of 0.1 GPM of foam over the top of your tank, over the surface of the tank. And all that stuff is carefully adjusted and basically put together on an individual basis for each one of your facilities. So now the question is, we can't use that anymore. We can't use that foam, that consistency of that foam, which really was the basis of the adduction. What do we do? So the new foam, the FFF, depending on the manufacturer, can either be, with the case of Ansell, and ChemGuard is a private label of Ansell. And I've been working with the Ansell R&D engineers for about 3 years. And, you know, phone calls back and forth and how you doing? Well, what do you think about this? Ansell has actually developed a fluorine-free foam that's 1-for-1 replacement. It's a drop-in if you have an Ansell system. If you have a National Foam system, a little bit different. National Foam's formula is not 1-for-1. National Foam in their UL listing tests found that their surfactant wasn't as fluid as some of the other brands, some of the other chemical compositions. So that doesn't flow as easily. So a National Foam system would be anywhere from like 1.2 to 1.8, 1.9, as opposed to 1-to-1. So that would require new equipment. It'd be a larger tank and a new adductor, larger adductors. So you may, and I may nobody knows right now. I'm just throwing this out. You may, if you have a national system, there's no rule that says you can't put Ansel foam in a national tank. So that may be an out, but we don't know yet. So national hasn't been through all of the labs and the acceptance. Ansel has. Now, for those of you with systems that have spray foam on a pump pad or a filter pad or a loading rack, in the loading racks we would use non-aspirated sprinkler heads to spray foam up in the top of the rack. Ansel has got a product coming out late fall that's going to be a foam concentrate that can be used, once again, one for one, on those systems where you have a sprinkler head or a spray nozzle or the curlicue pigtail style throw nozzle. So right now, you've got the AFFF in there, it works. So in the future, you're going to have these available to you for those systems. Well, they say, don't jump off the ledge yet. We're talking some serious money here. So, can we? All right, back to you.
Okay, under the Federal Aviation Administration now. And to help answer your question down there, they failed to meet their goal of October last year, I believe. So, but under their Reauthorization Act of 2018, they had a provision requiring the FAA to change its standards for firefighting at airports by October 2021 to no longer require the use of AFFF. In my opinion, they basically waited up until the last minute. They knew they weren't going to meet the goal, and they kind of punted over to the Department of Defense and said, you need to get this more or less. We know you're having a spec coming. We're going to adopt that, like they did the mill spec for AFFF. And then you get into FAR, or 14 CFR Part 139, requires the use of AFFF on the aircraft crash and rescue airport crash rescue fire trucks. Section 321 of that rule requires the handling and storing of hazardous substances and materials, identifies fire safety and fuel farm, but does not address foam. However, under the definitions of 139.5, foam is identified as AFFF. And as many of you know, the FAA has formally indicated that to the airlines that, in their opinion, the Part 139 also applies to the foam at the bulk storage terminals or airport tank farms as well.
So just when you thought that you had to just satisfy the FAA, look who came down the street. We've got the Nfpa rules and regulations, which are, by definition, part of the fire code. So they're in the back of the fire code. It lists all of these Nfpa documents as having the force of the code. So we've got the foam, the sprinklers, which is, and 13 is the sprinkler piping system. So the foam rules and regulations don't talk about pipe. We have to go to 13 to talk about the pipe and the deluge valves. And then we've got foam water sprinklers and water spray for the pump pads. Then we got the pump. Then we have testing. Then we have the chemicals. Then we have the NEC, the signaling, the fire alarm code, and a life safety code. And if that's not enough, we also have the fire code, chapters 50 and 57. Those are the two that deal with the subjects that we're talking about here, whether it's storage tanks or spray nozzles or loading racks, things like that. The building code, mechanical code, plumbing code, and then most jurisdictions have what we call local amendments. So if it's a more sophisticated, I'll say it that way, a more sophisticated municipality, for example, the New York Port Authority, they have their own rules and regulations, and everybody else be damned. Los Angeles, San Francisco, Houston, Dallas, Fort Worth. So each one of these places, they take these rules and regulations and they twist them to how they want to do it. And so any of your facilities, if you want to change anything, and when we go to the fluorine-free foam, they're going to get involved. So best off, get them up front. Bring them in the day before you decide to do it and say, here's what's going on. And the fire departments, by the way, and the building departments, they're totally aware of this too because they have a lot of foam. They got to deal with it. And then if that's not enough, as Joe was mentioning earlier, he didn't have something on his big wheel. Firefighter gear is loaded with PFAS. That's what makes it fire resistive. So the fire service is also in just a dither about this, how they're going to handle it, because the guys put this coat on and the pants and now they're exposing themselves to known carcinogens. And cancer in the fire service is now a big problem. It's being recognized finally as a big problem. So everybody's totally aware of this and everybody's on pins and needles. So they're not gonna say, sucks to be you, because it sucks to be them too. You know, so I think we're going to find that we're going to have a nice level of conversation to be had with the authorities having jurisdiction. So where do we go? Oh, is this you?
Yep.
All right.
Well, here's where we're at today. Is the codes and standards are still evolving. We recommend that at the tank farms, that the fuel farms, that the owner or the operator in this case investigate what foam systems and concentrates are currently in place at your facilities, and then collect records, review records to determine if there has been any past foam deployment events, and to continue to monitor the evolving regulatory situation, which we'll probably know a lot more where it's going at the start of next year, and then to consider the impact of the expected rule changes of which we're discussing here right now. So, but it's going to be it should be, if all goes to plan anyways, a very exciting year ahead of us. And then impacts to infrastructure. Studies have shown by the Nfpa that some of the FFF concentrates do not perform as well as the AFFF concentrates. And that's mainly meaning that they don't extinguish a fire of the same size at the same time. They require more fluorine-free foam quantity to extinguish the fire, that same size fire that AFFF could possibly handle, like say in 60 seconds. Could take 70 seconds for the FFF to do. Again, Ansel and ChemGuard recently introduced a UL-listed FFF product as a drop-in replacement, as Terry indicated. And in existing fire protections protection systems will presumably require expansion with respect to storage equipment, et cetera, since many FFF products require greater application rates to provide similar performance. I know, again, it almost is complete disagreement with the bullet above it, but if you're trying to mix and match one system with a foam from another manufacturer, you may find that you're going to be having to do some modifications to the existing fire protection system. The cleaning of equipment, cleaning of system components in contact with the AFFF concentrate will be required to be cleaned before replacement with AFFF, or dismantled and disposed off-site in an approved disposal facility. I don't know at this point in time what is going to be considered clean. There's triple rinses, water rinses that are being proposed to clean an existing, say, pipe versus there's some solvents that some patents have been taken out on by consultants and so forth, seeing that this is a very ripe opportunity in the near future here, that can say that they can clean a pipe of PFAS residuals. It's probably going to be very expensive, and either way you go, if you use a patented solvent or a triple water rinse, we don't know what that level of clean is yet, as to what the regulatory agencies are going to allow to stay inside a piece of pipe that's been exposed, a stick of pipe that's been exposed to AFFF and water. However, you may reach the conclusion too is how much are you willing to invest in cleaning of a pipe versus replacement of one. And so that's going to have to be considered on a site-by-site basis. And then also, if your system has ever deployed foam, you're going to have to clean it or you're going to have to replace it. You just don't want to contaminate fluorine-free foam with PFAS residuals. And then last is a given though, the concentrate, the AFFF concentrate, the foam bladders, the cleaning liquids are all going to have to be disposed as hazardous waste. Other environmental considerations are to consider too is here we are at the disposal methods for AFFF concentrate right now, and it's incineration, very high temperatures I indicated before, deep well injection, and landfilling the concentrate. Landfills can, a hazardous waste landfill, can mix the concentrate, the liquid, to make it a solid, and then put it in what they consider a secure cell in a hazardous waste landfill. I think it's the least preferred, and from what I've heard of others, is the least preferred method of disposal, whereas the incineration and the deep well injection seem to be the way that is the way right now to minimize your liability when it comes to disposal of a hazardous waste, and that's the PFAS. One note here is aircraft ARF units and aviation tank farms have used AFFF for decades. Laboratory testing for PFAS will likely be required when disposing of excess soil or petroleum impacted soil generated during a fuel and system improvement project. In my experience, just replacing a hydrant system lines by either removing them or replacing them with newer lines, you're going to inevitably come across petroleum contaminated soil. And it's not saying that it has PFAS in it, but the fact is that the ARF units have sprayed foam over the airport as needed. An engine fire, I've seen, they really make sure that they put that fire out. And where does all that foam go? It goes right into your infields. Most of which are grass covered. They have fueling pipe going through them at depth. And when we get in there to excavate and we have excess soil or we come across the impacted soil, we're going to take it off to a landfill. That landfill is going to want it analyzed for PFAS today. So to make sure that we're properly disposing of that material. So that's something I just saw is it could be an increase in cost as we're seeing on some of our projects we're working on, is that we're generating a lot of petroleum impacted soil, and in the future we're going to have to be analyzing for the PFAS in that. If anything, it's an added expense from the laboratory. Let's just hope that all the numbers that come back, there's no detections, which is ideal, but if there are, they're very low and below the standard that's going to be established by the EPA. And then from my own background, stormwater sampling for PFAS will likely be required at airport facilities. I can't help but think that, just like how they approach the whole de-icing fluids, is that right now, is that slide I showed early on, the airports have a big bullseye on them right now. And I can't help but think that there will be people advocating for sampling the outfalls and seeing if this is in there. And I think it's been touched on at some facilities, and I just can't help but think that they're not going to let this go easy. So I hope that makes sense to you, but I just kind of, the environmental people are really after this AFFF, or the AFFF regulations. For disposal, from what I've found out so far, and these are today's costs, this isn't hazardous waste. So right now, you can, in South Texas, AFFF concentrate typically ranges $3 to $6 a gallon to dispose of in a deep well. Incineration is typically $3 to $5 a gallon. Incineration of PFAS contaminated soil typically ranges from $400 to $600 a ton. That is not cheap. Disposal fee, and again, this is all costs based on a non-hazardous waste. Disposal fees are expected to increase once PFAS are designated hazardous substances by EPA. And that's in Lloyd's presentation on when that rulemaking is coming. So what should you do? And we've broken this down into 3 scenarios, and the first one of which is an existing facility. There's no planned improvements, for modifying the tank farm whatsoever. Just waiting for this regulation to come through. And again, wait till the mill spec is approved for use by FAA. Evaluate today if your existing fire suppression system requires upgrades for the transition to fluorine-free foam. And then cleaning of existing equipment will be required if it's been exposed to the AFFF. My advice is to coordinate with with your airline legal representative, environmental staff, or consultant for proper disposal of the concentrate, the bladder tanks, the piping, etc. This will include disposal of waste if cleaning of existing equipment is performed. Again, you're going to be creating a liquid waste stream by doing that. And then last is notify your authority having jurisdiction of planned transition to a fluorine-free foam system and update fire suppression system testing procedures. And that would be discussed with the authority having jurisdiction. For scenario 2, you're an existing facility, you have planned improvements. Design the fire suppression system using components compatible with the fluorine-free foam, and evaluate if existing equipment can be reused. And again, if it can be, if it's been exposed to AFFF, it's going to have to be cleaned in all likelihood. And that's what I can't tell you is what is considered clean today. How clean is clean? And then, of course, notify the authority having jurisdiction of the transition to the fluorine-free foam. And then, again, coordinate with the airline legal representative and your corporate environmental staff or your consultant for proper disposal of all the concentrate and other waste materials that you're going to be generating. And then, again, update the fire suppression testing procedures for the facility. And then the third scenario, improvements under construction. It's easy for me to say this, but delay implementation of any foam going into a new system, if you can. And again, you just don't want to introduce a AFFF to a piece of equipment only knowing that it'll probably be removed in the very near future and replaced with fluorine-free foam. So, and again, notify, again, I can't stress too much, but communicate with the authority having jurisdiction, as Terry indicated, of the planned transition to the fluorine-free foam. And then if you have, redesign your fire suppression system to make sure it is compatible with the fluorine-free foam. And again, communication is the key here. Coordinate with the airline legal representative and your staff or your consultant when it comes to proper disposal of any waste materials. And the last but not least, update the fire suppression testing procedures. And that's it.
I want to expand something on that last one we just saw. If you've got a system expansion and you're in the design stage or you're in the preliminary budgeting stage, continue what you're doing, but make sure that the designers, whether it's the mechanical or the fire protection or electrical or anybody, they're aware that these things can and will change. But we don't know to what degree. So to say that I'm going to have I'll give you an example. I know of one airport right now that's got tanks under construction. And what we're suggesting at this particular airport is don't do anything different. The system was designed using Ansel equipment. So go right ahead with what you're doing. But let's say, for example, it was designed using National Foam or Solberg or any of the other half a dozen foam manufacturers and their equipment. I would suggest at this point, stop. Let's let the dust settle. It's only going to be a couple of months, unless you desperately need those tanks back online. I would just cool it for right now because we just don't know. Now, the foam, the existing AFFF foam, runs roughly about $29 to $35 a gallon. The fluorine-free foam looks like it's going to be just a little bit more, maybe 8 to 10% more per gallon. But when you're looking at tanks that are going to hold 200 or 300 gallons, do the math. That's a lot of money to throw away if you're going to put AFFF in there just for 6 months or 8 months. It's your call. But just be really careful about that one. And of course, Argus is available to help you through any of these decisions with information to help you in your decision making. So we went through a whole lot here. And I'm sure I've seen a lot of note taking. Are there any questions that you have regarding what we talked about today? Anything? Orange Whip?